Ready now? All right, so this is the motherboard. This is the motherboard that I was just explaining the schematic, and in this practical I'm going to show you how to trace, right? Checking the isolation and protection circuit, right? So we're going to go on using the schematic for reference, where we're going to go through each step and using the schematic diagram. Hold on. The schematic diagram, and then we're going to go step by step, right? So first we'll do we already checked, so we're going to plug in the adapter now. Alright, plug it in. Alright, this voltage is roughly 18 voltage that's inserting now. Right, 18 voltage coming in, so we'll use our multimeter. Alright, we'll set our voltage to 20 volt range. Right, and we'll now check. And the input of this coil, see this coil. Let's go to the schematic. Here it is. So this is PL1, as you can see. This is PL1. So adapter coming through pin 1. So we'll check. This is PL1. It's not so clear on the schematic. See, this is PL1. So this should be 18 volts. So let's measure 18 volts. Good. This is 18.94. Right. So this is the coil. Right. Next, we'll go to the next page. Right. Input isolation. Right. See, V in. Hold on. So after coming through this coil. PL1 it will produce V in, right? Now V in is gonna come through PQ3 as drain, right? So PQ3. So this is PQ3, as you can see on the schematic on the board. PQ3 is coming to here. Pin number 5. This is source. This is drain. So pin number 5, 6, 7, 8. Pin number 1, 2, 3. This is gate. So this is source. This is the drain. So pin number 5 or 8 or any pin on this side you can check. You should get 18.94 voltage. See, this is 18.94. Remember, this is a damper diode. So PQ3 is acting as a diode because there's a body diode that's inside of it, as you can see. So no matter what condition the gate is on this MOSFET, it will just flow the 18 voltage to produce P2. So if we check the source on this MOSFET of PQ3, you should get 18.94, and the gate will be high also. Good. See, 18.84 voltage. Right, this is the voltage that we are looking for. 18.8. Before it was 18.9. See, it was 18.94, and now if you check the gate, it's what? 18.85 voltage. So that is the gate voltage, right? So no matter what voltage, it will just flow the 18.94 voltage because it is acting as a body diode. And the voltage at the, if you notice, the voltage at the gate is also same as the voltage at the source, but that has a slight of a 0 point difference on the gate, as you can see right here, right? And this is acting as a body diode, right? Now let's go to P2. So if you go to PQ4, right, PQ4 is on the next side. PQ4 is on the next side. So we'll check. Alright. So this is one, if you notice now, it produces P2 after leaving the drain to source. After leaving PQ3, it produces P2, so that it's coming to the source pins of PQ4, right? So pin number 1. Let's check pin number 1. This is the arrow indicating this is source. Pin number 1, 2, 3 source. This is gate, and these are pin number 5, 6, 7, 8 is the drain. So we'll check pin number 1. Look, 18.894, right? So it is flowing from pin number 1, 2, 3 of PQ3 of the source coming to the source pin of pin number 1 and 2. So this is the source. So let's check on the gate. The gate must be low. If the gate is not low of 10 voltage, as you can see, when adapter present signal comes to here, as I said before, the ground will shift over here. So PR14 and PR7 will become a pull on resistance, right? And therefore it will pull this voltage to 10.8 volt, 10.7 voltage. If this is not 10.7 voltage, we won't have a drain over here, hence P4 won't produce. So we need to check from here, and we need to check this operational amplifier here. We need to check this circuit to measure and check in these components to check if the working conditions is met from here to produce adapter presence. So let's check on the gate. The gate is too high. As you can see, the gate is 18.86 voltage. So this is a fault. Right, so let's check on the drain. 0 voltage. See, this is a P channel MOSFET, so the voltage at the gate should not be the same as the source. See, so the voltage at the gate is 18.8 and the voltage at the source is 18.94. so it should, the gate voltage should be 10 voltage. As you can see, the gate voltage should be 10 voltage, right? So we're going to look at the operational amplifier. We're going to look for PU2 on the board, right? So PU2, we're going to check the working conditions of PU2. Right, so PU2 is looking just like a MOSFET. PU2 just like one of these 8-leg MOSFET, and we are going to look for PU2, which is a LM393, right? So we're going to look for LM393. Aha, here it is. PU2, right? As you can see on the top of it, see? LM393 PU2, right? So we're going to check, right, P number 1. P number 1, see? 3.2 voltage, as you can see. P number 1 is 3.2 voltage, right? So let's check P number. So adapter presence is coming. Adapter presence is coming, right? So therefore, this MOSFET is faulty. So we should change this MOSFET and our problem is solved, right? So we're going to check the working conditions again. So we are getting adapter presence signal. See, let's go back to P number 1. This is P number 1 mark, LM393. P number 1 should be 3.2. Good, 3.2 voltage is there, right? So as you can see, 3.2 voltage is coming. 3.2 voltage is coming. So therefore, this is let's pick P number 3. So let's check P number 3. This is coming to a pull-down resistance, and it is being compared with this 1.2 volt ref, right? So it's higher than 1.2 volts, don't it? It is higher than 1.2 volts, right? It is higher than 1.2 volts. So it's comparing. So after coming through the pull-on resistance, it becomes 1.3 voltage, right? P number 2 should be 1.2 voltage. Beautiful. So our operational amplifier is working. So it is comparing. So 1.2 volt is less than 1.3. So it will output the high level of 3.32 volts here to produce adapter presence signal, right? So adapter presence signal is okay. So let's go back to PQ3, right? So let's check PQ3 now in full checking. Alright, let's check PQ3. Alright, PQ3 is dead. This is the fault. Right, so we change this and our problem solved. Thanks for watching.
Just like that?
Yeah.